Welcome to Understand All. I'm your host, Aslekeir Gairleif, and today we're embarking on an electrifying journey to unravel the mysteries of electricity. So grab your thinking caps, get comfortable, and let's dive into the fascinating world of electrons, currents, and circuits. Electricity is everywhere in our modern lives, from the smartphones in our pockets to the lights illuminating our homes. But have you ever stopped to wonder, what exactly is electricity? Well, buckle up because we're about to find out. At its core, electricity is the flow of electrical charge, typically carried by tiny particles called electrons. These subatomic troublemakers are always on the move, zipping through wires and circuits like cars in a bustling city. But what makes them move? That's where the concept of electric fields and forces comes into play. Imagine atoms as miniature solar systems, with protons and neutrons forming the nucleus, or the sun, and electrons orbiting around them like planets. Now, just like magnets, these particles can attract or repel each other based on their charges. Protons have a positive charge, electrons have a negative charge, and neutrons, well, they're the neutral Switzerland of the atomic world. This attraction and repulsion between charges is what creates electric fields and forces, governed by a set of rules of attraction known as Coulomb's law. But how does this translate into the electricity we use every day? That's where current electricity comes in. When electrons flow through a conductor, like a copper wire, we get an electric current. It's like a never-ending traffic jam of electrons, bumper to bumper, all moving in the same direction. The peer pressure that makes them move is called voltage, or potential difference. And just like a car encountering obstacles on the road, electrons face resistance as they travel through a conductor, which is where Ohm's law comes into play. According to the U.S. Energy Information Administration, in 2020, the average American household consumed about 893 kilowatt hours of electricity per month. That's enough to power over 30 refrigerators. But have you ever wondered how all that electricity gets to your home? The answer lies in circuits. Circuits are like the superhighways of electricity, connecting power sources to the devices that need energy to function. They're made up of basic components: a power source, conductors, and a load. In a circuit, electrons work together as team players, flowing in a single direction to get the job done. But sometimes, circuits can be more like solo artists, with electrons taking different paths to reach their destination. These are called parallel circuits, and they allow for more flexibility in how electricity is distributed. Now, here's a mind-blowing fact. Did you know that the Earth itself has a natural electrical circuit? That's right. The ground beneath our feet can conduct electricity, and this phenomenon is what helps protect us from lightning strikes. According to National Geographic, lightning strikes the Earth around 100 times every second. That's a whole lot of natural electricity. But the relationship between electricity and magnetism doesn't stop there. Have you ever wondered how generators and motors work? They rely on a fascinating principle called electromagnetic induction, discovered by Michael Faraday in 1831. It's like a secret handshake between electricity and magnetism, where a changing magnetic field can induce an electric current and vice versa. This dynamic duo is what powers everything from hydroelectric dams to the electric motors in your household appliances. Speaking of power generation, did you know that there are many different methods of generating electricity? Fossil fuels, like coal and natural gas, have been the old reliables for decades, but they come with a hefty environmental price tag. Nuclear power, on the other hand, is like the controversial cousin. It's powerful, but it comes with its own set of risks and challenges. And then there are renewable sources, like solar, wind, and hydropower. The eco-friendly gang that's been gaining popularity in recent years. In fact, according to the International Energy Agency, renewable energy sources accounted for nearly 29% of global electricity generation in 2020. That's a huge step towards a cleaner, greener future. But once electricity is generated, how does it get to our homes and businesses? That's where the power grid comes in. A vast network of transmission lines, transformers, and distribution centers that acts as the superhighway for electricity. And here's a surprising fact. The world's largest battery isn't some high-tech gadget in a lab somewhere. It's actually a hydroelectric plant in Virginia, USA. The Bath County Pumped Storage Station can store enough energy to power 750,000 homes for a day. Talk about a power couple. But as we delve deeper into the world of electricity, we can't ignore the great debate between alternating current, AC, and direct current, DC. AC is like a wave rider, constantly changing direction, while DC is more of a straight shooter, flowing in one direction. Each has its own advantages and applications, from the high-voltage transmission lines that crisscross the country to the batteries that power our mobile devices. And when it comes to electronics, it's all about the tiny switches, called semiconductors and transistors. These miniature marvels are the building blocks of modern technology, allowing us to create everything from smartphones to supercomputers. In fact, according to a report by the Semiconductor Industry Association, the number of transistors in a modern CPU can exceed 50 billion. That's like having a miniature city right inside your computer chip. But with great power comes great responsibility, and electricity is no exception. Electrical safety is crucial, as electricity can be a silent killer if not handled properly. From simple precautions like not overloading outlets to more advanced measures like ground fault circuit interrupters, GFCIs, there are many ways to stay safe around electricity. So always remember to respect the power of electricity and take the necessary life-saving steps to protect yourself and your loved ones. As we approach the frontiers of electrical science, we encounter mind-bending concepts like quantum mechanics and superconductivity. These resistance fighters and mind-benders are pushing the boundaries of what we thought was possible with electricity, from the development of quantum computers to the creation of materials that can conduct electricity with zero resistance. And let's not forget about the awe-inspiring electrical phenomena that occur in nature, like the northern lights. According to NASA, these mesmerizing displays are caused by charged particles from the sun interacting with the Earth's magnetic field, creating a celestial light show that's both beautiful and scientifically fascinating. So, where do we go from here? The future of electricity is full of exciting possibilities, from emerging technologies in power generation and storage to the development of smart grids and energy management systems. As we continue to unravel the mysteries of electricity and harness its power in new and innovative ways, the potential for breakthroughs in electrical science is limitless. But perhaps the most important question is, how will electricity shape our future? Will it help us solve the pressing challenges of our time, like climate change and energy access? Will it unlock new frontiers in science, medicine, and technology? One thing is for sure, the story of electricity is far from over, and we have the power to shape its next chapter. So, as we come to the end of our electrifying journey, let's take a moment to reflect on the incredible role that electricity plays in our lives. From the basic concepts of charge and current to the cutting-edge developments in quantum computing and renewable energy, electricity is the spark that drives our modern world. And that's a wrap for today's episode of Understand All. I hope you enjoyed our deep dive into the world of electricity and gained some valuable insights along the way. Remember, stay curious, keep exploring, and never stop learning about the amazing wonders of science and technology. Until next time, this is Aslekeir Gairleif signing off.